Good morning, everybody. Today we will present about project on the Sufficiency agriculture learning platform for the development of new agriculturists. My name is Kazuya komatsu.
My name is Pimlapat yoothong, and our advisor is Dr. Pornsuree Jamsri.
In this research, we divided into 5 parts. 1. Background and significance of the study. 2. Technology and tool used in development. 3. System design. 4. Summary. 5. Demonstration.
Let's start with first part on research background. Monoculture is growing a single plant by the farmer growing behavior that impact on agriculture. For example, oversupply and low production price as a result of monoculture or the cultivation of a single crop during the same period. When they are exported, they are also exported to the market at the same time. When we go back at the problem, we found low production price caused by oversupply, and oversupply caused by planting behavior. And last problem because farmer lack of knowledge about mixed crop. These are the loop of growing and selling agricultural products. We conducted a focus group with target group who want to be a farmer, have limited knowledge or native in agriculture, above 20 years, and has been doing agriculture for less than 3 years. Our objectives are: first, to develop an application that educates about planting and plant care for new farmers. Second, to help design and allocate area for planting. Third, to create a learning communication in order to exchange agriculture information with new farmers for cultivation. Fourth, to develop a mobile application for agriculture that supports in iOS and Android operating system. And fifth, to encourage farmers to grow mixed crops.
Next, part 2. Technology and tool in development. We divided into 2 parts, user interface and data management. User interface, we use React Native for developing so that support both iOS and Android. Easy to develop and has Apple application is a set of tools and services built around React Native that help develop and testing the design resource. Data management, we use Firebase for managing data. Database is a NoSQL. It provides many services to help manage data, such as Firebase authentication, cloud file store. In system design, we divided into 5 parts. 1. System architecture. 2. Use case diagram. 3. Gergun feature. 4. System scope. 5. Database design. System architecture. New agriculturists interact with the application Gergun for should plan to go, view watering schedule, exchange knowledge among user and community, and query interested user information. Then the system will show the result relevant to the user need. All data we keep in Firebase. We divided into 3 parts: user service, agriculture service, and notification service. This is use case diagram, 16 use case and 8 features.
Next, application feature. The first feature is a getting started. This feature has login and register for use this application. Picture 1 is login into application. Picture 2 is register with application. Next feature is the start planting. This feature help planting. Choose an area to plant, choose plant to plant, choose the site to plant, and choose the model to plant. Picture 1 is the choose plant to plant, and picture 2 is area and plant allocation. Next feature development process for start planting. User should buy area by put it in application, and then choose plant to plant. Finally, allocate area for plant. Picture 1 is determining an area by putting required info. Then the system will display the area according to that number. Picture 2 is choosing plant to plant. User can choose plants according to our system. Picture 3 is plant allocation. When user already choose plant, user can allocate to plant. Picture 4 is summarize the list of cultivated plants. Next feature is a plant information. The feature can select to see plant information. Picture 1 is list of plants in our system. User can search plant. And picture 2 is plant information. We divided into 4 topics: planting, clearing, plant disease, and harvest. Feature development process for plant information. User want to know plant information. System display all plant in all system. When user choose plant to see information, and then system display information which user choose by infographic.
Feature a chat room. User can post a question, comment a question, and live post or comment. Picture 1 is a process for into a chat room. Picture 2 is a chat room to encourage the learning community among farmers. Feature development process for a chat room. User enter a chat room to post some question for answer about agriculture from another user, and another user can comment or live post. Feature user information. User can view information and edit information. Picture is user information and user can edit information by click edit information. Feature going model. User can choose provide model to pan or view going model. Picture 1 is choosing a going model based on user area. Picture 2 is viewing a going model. Feature watering schedule. This feature offers users to view a watering schedule. However, the watering time reminder has some effect during development process, so we set it at this time and provide the prototype.
System scope. To get a clear scenario of using Kazuya application, our app based on the actual background information of 5 provinces on this slide in Northeast region. It is counted as the largest farmer population in Thailand and major agricultural area in country. Briefly, we found that Ubon Ratchathani had the largest population in 24.93%. This part is little plant in system. There are 10 selected types of plant in this system including: first, economic crops, rice, corn and cassava. Second, horticultural crops, red onion, tomato, chili, long green bean pod. And third, fruit tea, durian, longan, and coconut.
Database design. Inside Cow File Store, we store 6 collections, 1 collection or post, 2 collection following, 3 collection model, 4 collection plant, 5 collection user, 6 collection user location. Today we present only 3 collections. Collection or post keep all question data. They are field creation, image URL, like, question, user, and there is sub-collection is comment and like. Inside comment we save all comment of question. Inside like keep user who like the question. Collection plant is keeping all plant data. They are field color, icon, name, suitable, popularity, watering, types. Collection user location is storing all area data that consist of field area, coordinate, required number, owner, land number, polygon, and province.
Finally is summary. We divided into 4 parts. First, result and evaluation. Second, conclusion. Third, operational barrier. Fourth, future research. This slide is result and evaluation. When we conducted user testing by using the application, we will provide a scenario that covers all use cases of the system and observe user interact with it. Then we bring that data for analytics. Scenario has the following: getting started, start planting, see detail of each plant information, exchange idea with other farmer, change profile picture, see preference of user, and see a watering schedule. This slide is show the average score of the test in each of the 10 user groups. Full score is the 5 points, mean the best, and 1 is the lowest. We divided into 3 parts. Overall usage has score of 4.2. Application artifact had 4.3. Response speed of application got 3.1. This slide demonstrated the average score by expert group. This score represents the same as user group. Full score is 5 points. We divided into 3 parts. Overall usage got 4. Application artifact got 4. Response speed of application had 3.
Conclusion suggest from expert. The overall test result of the application will found that the plant data included in the application is proper. If more various plant information is added into the application, it will be benefit naive farmer. The usability is complicated. Some parts need to be simplified. Gurkun application had a features support both iOS and Android operating system. Was developed under the idea of giving farmers access to useful resources. Problem in testing. There are some features that need to optimize more, such as set preference of user and user information features. Saving other user information that had edited by adding the post history of each user will be benefit more. Performance of application was slow at the testing, then the researchers solved by using lazy load. The comparison between Gurkun and Chao-Kase agricultural application. Gurkun application has more features than Chao-Kase agricultural application that are missing. For instance, Gurkun provides plant area allocation, watering schedule and notification, interest agriculturists, a chat room, and choice of prototype model. However, Gurkun application is missing one different feature, such as tracking crop features. Feature research, adding an AI system that can recommend the right crop to grow in specific area. Developing plant disease analysis from photo by using image processing technical. Developing a tracking system for each plant. Operational barrier during developing process. We were facing for data problem. Some data are outdated. Agricultural data need to be organized. In the case of development problem, we need to test with a variety of users to simplify the application when possible. The technology used in development was changed from MongoDB to Firebase. As researchers' problem, time consuming with learning new technical and tools. Researchers spend more time than planned in research to adjust the plan according to circumstance.
The last topic is a demonstration Gurkun application demo. When the user enters Gurkun application, user must register and log in to use this feature. When the user has successfully logged in, the screen will show the name, profile picture, weather, and watering schedule. When pulling the screen to the right, the screen shows all the features. The first feature is user information. User can edit profile. The next feature is start planting. User enter the deed. The screen will show area information. User can choose plant from the model or can custom plant themselves. In the example, it will show you the selection of plant in a custom style. By selecting the plant to be planted, if select plant not seasonal plant, the system will display a warning message. When the selection of plant is complete, user will enter the amount of space in each plant and can decide that all plant plot. When finished, the system will display a summary page of the list of plants, and on the first page will show the watering schedule of plants. The next feature, My Plant, will show you the detail of the plant we are currently planting. The next feature, Watering Schedule. User can edit the watering time. In the next feature is the chat room. User can post photo, post message, like, and comment. The next feature is plant information. The system displays all available plant information in the system in the form of infographic. User can view the cropping model in the system. Thank you for your attention.